Thank you very much. Good afternoon, everyone. I'm going to talk about SEACAMS, which has been mentioned once or twice today already. For those who don't know what SEACAMS is, it's a WEFO-funded project, funded through ERDF, led by Bangor University with Swansea University. And the aim of SEACAMS has been, since its inception, bringing expertise and facilities from the research community to the commercial sector. In its early days, SEACAMS1 covered a very broad range of marine activities, and we collaborated with about 100 companies. But in SEACAMS2, we are focused on marine renewable energy, and specifically, not surprisingly, in 3 areas. So the Anglesey Tidal Stream Demo Zone, the Pembrokeshire Wave Energy Demo Zone, and then tidal lagoons in North and South Wales. And I should emphasise that the way we work is by developing collaborative projects with businesses in the marine sector, and we can provide expertise, observational and modelling expertise, and then facilities, seagoing facilities like the research vessel and laboratory facilities, etc. And rather than going through a list of projects, I just want to give you a few examples of the kind of collaborations that we have at present. So, obviously, we're doing a lot of work in the Anglesey Demo Zone with Moorlice. Before working there, this was a rather unknown area. Unknown because, by and large, oceanographers didn't want to go there because it's such a high-energy region. It's very high risk in terms of deploying instruments, etc. And also, we thought it was going to be a very, very boring area. But we've now done a lot of very high-resolution surveys of the seabed, and you can see that it's actually extremely variable. We thought it would be very homogeneous. Actually, it's extremely variable. Yes, there are big areas of exposed bedrock. Yes, there are areas of gravel and coarse material, but there are also great swathes of very mobile sand in the form of sand waves, meters high, tens of meters high, which is not great news if you want to install something on the seabed. So we've done a lot of very high-resolution multi-beam surveys of the demo zone. And of course, that's really important from the point of view of site selection, but also when you're wanting to assess environmental impact, the impact of the environment on devices, and of course, the impact of devices on the environment. And clearly, we're looking a lot at the hydrodynamic environment of the demo zone. Initially, simply to characterize and quantify the hydrodynamic resource, but this shows something that we are doing recently. On the left there, in the 2 contour plots, those are assessments of the available energy. On the left, it's the available energy as is, and then the one to the right is the consequence of setting up an array of 30 devices, which are in that little square that you can see more or less in the middle of the contour map. Now, it might be difficult to notice that there's any big difference between them, but if you look on the flooding tide, and the curve at the top shows where you are in the tidal cycle. So if you start looking at that square now, you can see that downstream of that array there is a considerable reduction in the available energy. On the right, we've got an assessment of what individual, or in this case, a pair of devices on the seabed, what effect they have on the current regime. And then we can move on from this to look at the impacts of the hydrodynamics on sediment transport, and how sediment transport changes the geometry of the seabed, and that then feeds back into the hydrodynamic models. And we're also looking at how surface waves interact with the currents in this region. At Swansea, we've got this really excellent new facility, a flume, which of course enables us to do all sorts of things we can't really do at sea or in the field. And specifically, this instrumented flume can look at the hydrodynamics, it can look at wave characteristics, it can deal with sediment transport. So we can do model studies of nearshore hydrodynamics, the effects of breaking waves, swash zone dynamics, etc. But we can also look at wave forces on particular structures and use the flume to test marine energy devices. And you already heard about this earlier from Wavetricity. This is an ongoing or about to start project which is using the flume to optimize the design of the device which Wavetricity is developing. So you can test a device under different wave conditions, so you can optimize the design of the float to improve the power takeoff. And that allows you to get greater efficiency of power extraction and, of course, ultimately better performance and hence commercial viability. But I guess most of what we do is actually out in the field and at sea. And at Swansea, we are really focusing on the foreshore, on the beach, which is really important to tidal lagoons, but is also important because if you're bringing cables across the shelf to the grid, you have to go across the foreshore. So we're using new methods to assess morphodynamics of the coastal zone of the beach. And that's using, for example, terrestrial laser scanning and also testing the usefulness of drones to give a spatial perspective on foreshore morphodynamics. At Bangor, we're focusing on the shore face, and the shore face is that part of the inner continental shelf which is routinely stirred by waves, and in the areas that we're working in, that means it's an area of intense wave current interaction. And the shore face, which is between, say, 5 meters and 25 meters water depth, the shore face is extremely dynamic for that reason. And if you're going to build a tidal lagoon, you're going to build it on the shore face. So this particular part of the inner continental shelf is really important. Turns out we don't know a lot about the shore face, and that's because the guys who work on the beach don't go any further seaward than they can wade, and oceanographers in their ships and boats can't get very close to the shore. So there is a zone, the shore face, which is relatively unstudied, but it turns out to be highly critical in terms of, for example, tidal lagoon development. So we are establishing a system of instrumented observatories which can sit on the seabed in the shore face, sending back critical physical and sediment data in real time about the dynamics of the shore face. This is an example of work that we're doing with Monesto in Holyhead Deep. And this is the water column work. As I said before, we haven't really done much work in this region. The geological oceanographers thought it would be boring. The marine biologists thought it would be boring. It actually turns out to be really quite complex. And And for example, in the bottom picture there, so that's the water column, a time series of the water column over about 6 hours, coming out of the night time on the left towards midday on the right. And that's just an acoustic record of biological activity in the water column. And you can see, quite unexpectedly for us, there's an awful lot of activity in the middle of the water column. We don't know why, but that is a very clear signal. And that's really important, probably fish, but it's really important when it comes to assessing the impact of a device like Minesto's underwater kite. At Swansea, we are using acoustics to, first of all, quantify fish in the water column, but more ambitiously, to identify what kind of fish are in the water column. And this is really cutting-edge acoustics work, and clearly of considerable importance to operators who are going to be putting devices in the water column. So we are using these acoustic methods to give us a lot of information about fish behavior, fish migration, etc. A big concern, as everyone knows, a big concern is marine mammals. So in both North and South Wales, we're doing quite extensive research on marine mammals, about which we know relatively little, much to my surprise. But clearly, we need to know how marine mammals will respond to a device like Minesto's device. So we're developing methods, mostly acoustic methods, to detect the movement and migration and behavior of marine mammals like dolphins and porpoises. And at Swansea, we're looking at, or using, acoustic methods, again, to look at the behavior of fish, and in particular, their behavior on timescales which are seasonal, diurnal, and tidal, and also to develop the most cost-effective and efficient survey methods for actually gathering and assessing the data. And this includes more marine mammals research. And then finally, in SEACAMS, we are obviously collecting an awful lot of data. And that is data that is required by our collaborators. And we have found in SEACAMS that we are, in the research community, are actually rather bad at getting data that companies want to them on the timescales that they want. And existing databases like BODC at Liverpool are databases which have been designed by researchers for researchers, not really for other stakeholders. So we are developing a new data and information system in SEACAMS, first of all, to allow our collaborators to access the data they want, to access it in the form they want, the kind of data that they want, and also to provide them with tools to interpret the data that they can access, that we can give them. And I'll end there. Thank you.